For decades, humanity has pursued the ultimate energy source. But the answer has always been right in front of us. Hi, I'm Peter Sandberg, and welcome to Entropy Overload. On this channel, we dive into the fascinating world of physics, chemistry, and all things science. Join me as we break down the science behind splitting atomic nuclei. At a time when the frontiers of the periodic table were being actively explored, the scientific community was captivated by the possibility of synthesizing new elements, pushing beyond the known limits of matter. The element uranium, the heaviest known at the time, held particular fascination. Many researchers believed that by carefully bombarding uranium with neutrons they could be captured, leading to a cascade of nuclear transformations. Think of it like throwing extra bricks at a building, hoping they would stick and become part of the structure. This idea would be explored by scientists Otto Hahn and Fritz Strussmann. Otto Hahn was a highly respected and meticulous chemist. Hahn had dedicated decades to the study of radioactivity and the behavior of atomic nuclei. Fritz Strussmann, a skilled and dedicated chemist. Although he didn't have the same international reputation as Hahn, Strussmann was an indispensable partner in the laboratory. These two scientists, Otto Hahn and Fritz Strussmann, were about to make history. Though their goal was to build heavier elements, their experiments would lead them to an astonishing and completely unexpected discovery. The pair would be working at the prestigious Kaiser Wilhelm Institute for Chemistry in Berlin. It attracted some of the brightest minds of the era, fostering an environment of intense scientific inquiry and groundbreaking discoveries, particularly in the fields of radioactivity and atomic science. Hahn and Strussmann's work began with what seemed like a straightforward continuation of existing research. They were systematically bombarding uranium with neutrons, expecting to create even heavier elements, just as the prevailing theories predicted. It was meticulous, careful chemistry, precisely the kind of work Otto Hahn had perfected over decades. They carefully collected the daughter products of these bombardments, those new elements they believed were being formed. Then came the painstaking work of chemically identifying them. This was Fritz Strussmann's domain, separating tiny amounts of these radioactive substances and identifying them based on their chemical properties, a task demanding extreme precision and patience. For months, the results were baffling. They expected to find elements near uranium on the periodic table, perhaps some slightly heavier ones. But instead, as Strussmann analyzed their samples, they kept finding traces of barium. Barium is an element far lighter than uranium, roughly half its atomic weight. This was completely unexpected. Remember our analogy of throwing bricks at a building, hoping to make it bigger? Well, instead of making the building bigger, they found that their bricks had somehow caused the entire structure to fall apart, along with an enormous release of energy. This was scientifically impossible, according to all known nuclear physics at the time. How could a uranium nucleus, atomic number 92, transmute into barium, atomic number 56, by simply absorbing a neutron? It defied logic. Hahn, a chemist, initially struggled to believe his own chemical results. The scientific implications of Hahn and Strussmann's baffling results were profound, challenging the very understanding of nuclear physics. Yet, the quiet world of scientific discovery was about to be shattered by the eruption of global conflict. In September 1939, the invasion of Poland marked the beginning of World War II, and the potential of this newly discovered atomic phenomenon would quickly be viewed through a starkly different lens, the lens of military power and the urgent need for a decisive advantage. During this tumultuous period, Otto Hahn and Fritz Strussmann continued their nuclear research in Germany under the Nazi regime. However, their focus was on developing a nuclear reactor for energy, not on creating a weapon. Meanwhile, some scientists were able to escape Nazi persecution and continue their research in other countries, bringing with them invaluable knowledge and a profound concern about what Germany might be developing. This fear was palpable. What if Nazi Germany, already a formidable military power, managed to harness this incredible new force? One such scientist, Hungarian physicist Leo Szilard, convinced Albert Einstein, the world's most famous scientist, of the urgency of the situation. In August 1939, Just weeks before the war officially began, Einstein signed a letter to U.S. President Franklin Roosevelt, warning him of Germany's potential to develop an atomic bomb and suggesting that the U.S. should pursue its own research. By late 1942, this effort turned into a secret, unprecedented undertaking, the Manhattan Project. This was no longer the quiet work of a few scientists in a university lab. The Manhattan Project became one of the largest and most ambitious scientific and engineering endeavors in history. Its sole, singular purpose was to design and build an atomic bomb before the Nazis could. The discovery of nuclear fission had unleashed an unimaginable power, and now, with the world at war, the race was on to harness it. But how would they achieve such a monumental feat in secret? And what would be the ultimate cost? If you found this journey into the surprising origins of nuclear fission fascinating, please like this video and subscribe to Entropy Overload for more deep dives into the captivating stories behind scientific discoveries that changed our world.